So in this session, we'll start with the directivity, gain and efficiency, which are more crucial for your antenna design. Okay. So in this case, this directivity, as I have said during the radiation pattern as well, it will depict the directivity, or you can say the directional, how intense your field strength is. Okay, and generally it is expressed in dBi. Gain will be expressed in dB, and gain whereas in case of directivity we say that strength of the radiation intensity, and in case of gain it will signifies the power in a specific direction. Okay, that's why it is having a u theta of phi, because theta and phi means it is giving a coordinate angles at which it is having a gain. And regarding this 4 pi, this is the formula is coming as z is equals to u of theta phi divided by input power. So input power, and that too, this 4 pi means a sphere it will take place, because of in each direction we'll say generally. Okay, standard definition I have also mentioned in both the cases, directivity and gain. As you can see this, the ratio of the radiation intensity in a given direction from the antenna to the radiation intensity average over all directions, means whatever the direction directivity, whatever the energy it has been emitting, so it has to be in specific direction, and what all the directivity means, the rest of the energy it is producing in other direction, right, to rest of the direction. So the average radiation intensity is equal to the total power by the antenna divided by 4 pi. So total power means total power divided by 4 pi. So suppose u are given, u divided by u naught. Okay, but u naught is nothing but the p radiation, whatever the power radiation, divided by 4 pi. Okay, so if the direction is not satisfied, the direction of the maximum radiation intensity is applied. Okay, in case of gain, if you will see that the ratio of the intensity in a given direction to the radiation intensity that would be obtained if the power accepted by the antenna were radiated isotropically. So since it is having an isotropically radiation, that's why we are considering it as a 4 pi, means as a full sphere. Okay, then further, radiation intensity corresponding to the isotropically radiated power is equal to the radiation intensity corresponding to the isotropically radiated power is equal to the power accepted input by the antenna divided by 4 pi, means p in divided by 4 pi, and 4 pi will goes to the numerator. Okay, then further, efficiency so other formulas are also there, but in case of this just for a rough definition, I have made it. So when generally we will say that I have already told that maximum power will transfer once if the load impedance is equal to the source impedance. Okay, and in case of suppose in this case antenna, so if the losses means impedance at the port side it is not matched fully, then mismatch will occur, and in that case efficiency will reduce. Okay, so efficiency can be said as gain is equals to eta multiplied by d, that is eta is nothing but the efficiency. So from there you can find out the ratio of the efficiency. Now whatever we have studied is the normalized gain. Now this is realized gain also, and in case of CST as well, but anyway in this course I am not discussing a realized gain, we are discussing gain S11 VSWR and impedance, like that we will consider. Okay, so so the realized gain means when losses are not accounted, or you can say losses are not counted during the realizing of the gain or any other parameter, then we are saying realized gain. In case of CST file gives the example, generally it is realized gain is somewhat lesser only, whatever the gain it is showing in the normalized way. Okay, gain IEEE it is having, and realized gain two options will be there. So in that time also we are seeing only the normalized gain. Okay, now further, this is also having some of the formula for it, which is based on the gain which accounts the losses generated due to the mismatch or any antenna losses. Okay, so gain is having a 4 pi radiation intensity divided by total input, or you can say the accepted power, that is PIN. That same only what we have studied in the previous slide. Now radiation power is nothing but the ECD, that is one kind of parameter only, accepted power PIN. Okay, and efficiency only. And in this case of G theta phi,